My name is Walter Unglob, and this is how to convert a light pulse back into an electrical signal. There are several ways to do this. One common way is to use what's called a photomultiplier tube, or just PMT for short. In this device, we exploit a very interesting and important phenomenon known as the photoelectric effect. The photoelectric effect essentially involves photons, which are quantized packets of energy of electromagnetic radiation that are propagating with some frequency, and the higher the frequency, the higher their energy. So as these packets of energy, these particles of light, enter the photomultiplier tube, with some energy, if the energy is sufficient, they can knock electrons off this metal or this material. In the photomultiplier tube, these walls, these surfaces, are known as dynodes. D-Y-N-O-D-E-S. Now, when a couple electrons are knocked off the first dynode, they'll be attracted to this other dynode, and more electrons will be rejected from that material. So you end up with a cascade effect of many, many electrons just from one or two photons initially hitting the first dynode. When this happens, you end up with a sizable electric field and electric current, because you have many charged particles moving in some unit or interval of time. When this happens, you can detect a sharp electrical pulse due to this photon impinging upon the first dynode. And if you have many photons, then you can see an electrical signal in an oscilloscope, for example, or some sort of scope that you would hook up to your photomultiplier tube. So this is how you can generate electricity or an electrical signal from light, just from using some sort of detector. In this case, the photomultiplier tube takes advantage of the photoelectric effect, which means that these particles of light can knock off electrons, which will generate that electrical signal. My name is Walter Unglob, and this is how to change a light pulse back into an electrical signal.